This is a tutorial for the simulation Diffraction and Interference. And this simulation actually does all sorts of stuff. When you first load it up, it's actually just a diffraction simulator. And so we've got our incoming waves, and of course we have our gap. And what you can do is move the gap up and down. Of course, we get no circular pattern when it's larger than the wavelength, but as you get close to the wavelength, you get your nice semicircles. If you want to exactly match it to the wavelength, you click on Max Diffraction, and we get something very nice like that. We get a comparison of the wavelength versus the gap width here in the bottom. And if you like, you can adjust the wavelength to make it smaller and click Maximum Diffraction again to get our very nice semicircles through that. If you find the detail a little bit too low, you can increase it to medium and high. You may find that high is a little bit too much for your computer, and right now, because my computer's been on for a long time and overheating, you can see it's quite sluggish, so I'll move it back to low detail. You can also choose 3D mode, which gives you kind of, maybe I'll put it on medium detail. It gives them kind of a 3D perspective, so you can see the actual peaks and valleys here. It looks quite nice there with a longer wavelength. If you click on mode again, you can go to a double slit mode, and this of course simulates a double slit just interference pattern, not necessarily a Young experiment, but you know, you would get this with water, of course. And so you can play around with the wavelength to make it look nice, and you can clearly see these nodal lines here. And if you click on the interference pattern, if you click in an antinodal region, you can see that constructive interference, whereas if you click near a nodal line, you can see that they're actually out of phase, so they cancel out. So that's a little adding touch I added there. If you click on screen, it will also show you, of course, where you get constructive interference as being brighter and destructive as being darker. If you pick Roy G. Biv, this now simulates a Young double slit experiment where you can choose different colors. So now this screen actually represents shining, you know, that laser through the two slits onto the wall, let's say. And you can adjust things like the distance from the slits to the actual screen, which is one of the parameters you can adjust when you derive this equation. You can adjust the separation of the two slits and see how it impacts the interference pattern on the wall. And you can, of course, adjust the wavelength for different colors, which will, of course, adjust the width of the bands of the interference pattern on the wall. So that is double slit mode. You can even do a lab version of this. What the lab does is it actually gives you real values that can be measured with this ruler, and you can work backwards to find the wavelength of the light. You guys can see that there's kind of a question mark there. If you unselect lab, it gives you the answer, but every time you click lab, it picks a random wavelength. And what you can actually do here is you can use the ruler to measure the separation of the slits, which is in micrometers, 6.9 microns. And you can also use that ruler, you can just drag the whole thing over here, and you can use it to measure, you know, let's say 3 delta X's. Okay? And then you can, of course, use that ruler to measure the distance from the screen to the sources. So you can use that and use your Young's double slit interference pattern equation to work backwards to try and figure out the wavelength of the light. So that's another option. The last mode, let's get rid of lab mode and Roy G. Biv mode. The last mode is just kind of an open two-point source interference pattern mode. So you can move the sources wherever you want. And you can still click on different areas to see, you know, antinodal regions versus nodal lines. You can click Show Crests and Troughs, and it gives you a nice little visual of how they overlap. If you remove the 3D version, you can, let's say, slow down the sim speed to pause, and you can really show the kids that right here we have a crest overlapping with a trough. And so we get our destructive interference at that location. And you can discuss the presence of nodal lines. So that is the wave interference and diffraction simulation. I hope you enjoy it.